Fifth graders, welcome back today for some more awesome science on light. You know you love it. So hopefully you guys are doing good and getting along well with your assignments and everything's going okay. I want you to think for a second about when you bounce a basketball. A lot of you guys are on the basketball team. You bounce basketball from yourself to another person. So you bounce it down and then it pops back up towards someone, correct? All right, so what we're going to look at today is light reflecting, and it reflects in a very similar manner. So you can see even on these pictures here, different surfaces allow it to reflect in different ways. So really a smooth surface is very similar to the basketball bouncing on the floor. You throw it down, it bumps up and hit into your whoever you're passing at, hopefully, unless the other team steals the ball, which is a very bad thing, and we don't like it when that happens, right? All right, so let's start reading. We are on page 248. Again, you can follow along in your textbook, or you can just follow along as I read to you here with this video. Mirrors. Have you ever bounced a ball against a wall? Light reflects off different surfaces in much the same way a ball bounces. When light shines at an angle onto a smooth surface, the light bounces off at an equal angle in the opposite direction. Mirrors reflect light in this way. When light shines on a rough or bumpy surface, the reflected light goes in many different directions. Some surfaces, such as paper, look smooth. However, if you use a microscope to look at a piece of paper, you will see that the surface is rough. So light that reflects off the paper will go in many directions. All right, so rough surface, many see one's going this way, it's going all over the place. And then a smooth surface is like we talked about that basketball. It goes in the opposite direction that it was bounced from. Rough surfaces such as paper and snow reflect light, but they do not make good mirrors. Mirror surfaces are shiny and smooth. A mirror is any surface that can reflect light to form an image or picture of an object. You probably looked at yourself in the mirror this morning. Hopefully. Maybe not. Some of you guys probably rolled out of bed in your pajamas and showed up for this, right? A mirror with a flat surface is called a plane mirror. Most common mirrors, such as the bathroom mirror, are plane mirrors. A plane mirror shows an image that looks exactly like the real object. The only difference is that the image is reversed. Okay, you probably have noticed, like you lift up one side of your hand and it's really on the mirror, it looks like the other side. Mirrors today are usually made of glass that has a silver coating on one side. In Bible times, mirrors were sometimes made from materials such as silver or bronze. The metals were polished until they shone. Exodus 38:8 tells us that the brass laver in the tabernacle was made from looking glass or mirrors. The Israelite women willingly gave their mirrors to be used in the tabernacle. All right, you may have noticed that the front of an ambulance has the word ambulance written backwards. This is so a person driving in a car in front of an ambulance can look in the rearview mirror and read the word clearly. This lets the person quickly know to get out of the way. All right, so you can see here in this picture that it's written backwards for that reason, because we see an opposite in the reflection. Some mirrors are curved. Curved mirrors change the way an image looks. They can make the image look larger or smaller than the object really is. You may have seen curved mirrors at a fair or an amusement park. The amount of curve can vary. Some mirrors curve a lot. Others have a curve so small that it may not even be noticeable. A mirror that is concave curves inward, like a cave. Think about it like a cave goes into the rock, so that's a concave mirror. These mirrors reflect light toward a point in front of the mirror. If you stand close to a concave mirror, your image is magnified or made larger. Many women and men use concave mirrors when they put on makeup or shave. This kind of mirror allows them to see better detail. Some telescopes use concave mirrors. These mirrors help faraway objects look bigger. A mirror that is convex curves outward. These mirrors reflect light that spreads outward. Images seen in a convex mirror look smaller than the objects really are. You can use a convex mirror to help you see a large area. Many stores use convex mirrors to watch for shoplifters. In automobiles, side mirrors are convex mirrors. So here's an example of the concave goes inward, convex goes outward. You might have seen these like on the side of roads, like in a blind spot. They're used to kind of see if like use it like bus stops a lot, or places where you can't see to get in and out of like to turn like in an area that's a blind spot, they'll have one of these mirrors up so you can kind of see better and see what's coming. So you've probably seen those on the side of the road before. Light and technology. All right, so we kind of talked about the X-ray machine a little bit ago. We were talking about Marie Curie at the beginning of the chapter. An X-ray machine is just one tool that has been developed from the study of light. There are also many other inventions that make use of light. What do some telescopes, lasers, and cameras have in common? They use mirrors and lenses to change the direction of light. A lens is a piece of glass or other transparent object that refracts light and produces an image. All right, so here's your reflecting telescope. And then you've got a camera there too to kind of show you what we're talking about here. All right, so let's look at the rest of this. Telescopes help people see things that are far away, such as planets and stars. Some telescopes are small, others are huge. The Subaru telescope, located in Hawaii, weighs 555 tons. That is more than the total weight of 56 buses. Regardless of size, however, all telescopes use mirrors or lenses, or both, to collect and bring the light to a point or focus. A reflecting telescope uses a concave mirror to gather and focus light. The light is reflected to the eyepiece lens, which magnifies the object. A refracting telescope usually uses two convex lenses. One lens gathers the light, the other magnifies the image. Science and history. Early camera-like instruments did not produce lasting images like photographs. They were mainly used to help artists sketch their pictures. In 1826, Joseph Napier, I might not be saying that right, took the first true photograph. He coated a metal plate with a light-sensitive chemical and placed it inside a camera for several hours. The photo showed the view from his window. Sorry, guys. All right, let's look at lasers. Sorry, I need to get a drink of water. All right. So, lasers. Cameras also use mirrors and lenses, where there are many kinds of cameras, though, and each works in a slightly different way. A single lens reflex camera uses a mirror and a lens and a prism. Lasers use mirrors to produce a thin beam of light that is very powerful. This beam of light is only one color. Inside a laser tube is a medium for the light to travel through. This medium can be a gas or a liquid or a solid. At each end of the tube is a mirror. As light travels back and forth through the medium, the mirror is reflected. One of the mirrors in the laser is semi-transparent. It reflects some light and lets some light pass through it. Some of the light leaks out of the tube through the mirror and produces the beam of light. The color of the laser depends on the type of medium that is used. Ruby lasers have a solid ruby rod inside the laser. These lasers give off red light. Other lasers with red light may use a gas instead of a ruby. Different gases can cause lasers to give off blue light or green light. Lasers can be found almost anywhere. DVD players and CD players use lasers to read the content of a disc. Checkout scanners in many stores use lasers to read barcodes. Doctors sometimes use lasers to perform delicate surgeries or to look inside a patient's body. Some lasers cut cheese into fancy shapes. Others are powerful enough to cut through steel. So lots of uses for lasers. All right, that is it for this today. You'll have some stuff to do along with this. Let me know if you have any questions about anything, and I will help you. Good luck, guys.